For this video, I'm going to be talking about the ELISA assays. These are used for detecting antigens or antibodies in blood serum. And there are three different methods that are used: the indirect method, the sandwich method, and the competitive method. So for each one of these, I'm going to go through the steps and specify which method detects what and how they're used. So for the first method, the indirect method, this is used to detect antibodies, or a specific concentration of antibodies. So for the first step, I've drawn the well for each step here. And in the first step, the well will be coated with antigens. Antigens that are specific for the antibody of choice. So for the second step, the primary antibody, AB1, is added in a fluid sample or serum. So these are antibody 1, the primary antibody. So in between steps, wash away any free antibodies. That may be floating around in the well. So for the third step, the antibody 2, a secondary antibody that has an enzyme bound to it, is added to the serum, and the antibody 2 binds to the primary antibody. So there's the primary antibody. So the secondary antibody here binds to primary. It has an enzyme attached. So I'm going to draw these enzymes. I'm going to draw Pac-Man enzymes. So add antibody 2 with enzyme. So for step 4, a substrate that is specific to that enzyme is added. I'll draw that. Okay, so here I'm going to draw the substrate bound to the enzyme. So then the reaction product will either produce color, fluorescence, or luminescence depending on how it's labeled. And then the amount of the product is measured using a specific plate reader. So the color could be lighter if there's not much fluorescence. in red. Okay, so here is the product producing color or radio label. So it can change the color of the whole well if it's supposed to produce a specific color. Okay, so also I was going to mention with the indirect ELISA, the indirect is also used to detect the presence of serum antibodies against HIV, which leads to AIDS. So this is also used for detecting that. Okay, so for the sandwich ELISA, the sandwich ELISA is used to detect antigen or cytokine concentration in tissue cultures, in serum, and in body fluids. So for step 1, it's going to be the opposite of the indirect ELISA method. You attach antibodies that are specific for the antigen. Just AB. Okay, let me draw those antibodies. Okay, in step 2, the sample of the unknown amount of antigens. So some of these antigens may be specific to the antibody and some may not. So here's the antibodies with the antigens that are specific to it bound. Okay, so in between these steps, wash away any free antigen that was not specific to the antibody. Okay, so for the third step, it's going to be like the step above. A secondary antibody is added to the solution with an enzyme attached to it. So the antigen is sandwiched in between these two antibodies. Draw Pac-Man enzymes again. So like in the step above, a substrate is added that is specific to the enzyme. So I'm going to draw the substrate bound to the enzyme here. And then the reaction product producing color or luminescence. Alright, so the third and last ELISA method is the competitive assay. The competitive assay is a more sensitive version of the sandwich because it can detect very sensitive amounts of antigens. So where the sandwich method can say if there's antigen in the serum, the competitive you can find the specific concentration of antigens. And the competitive is inhibition. So the first step, an antigen an antibody is incubated with a solution that has an antigen attached. So the more antigen that's available in this step, the less free antibodies there are to bind in step 2. So in step 2, it's coated with antigen. So this antibody antigen complex is added here. It binds to the antigen of choice. So then the free antibodies are washed away. So a secondary antibody with an enzyme attached that's specific for the antibody 1 isotope is added in step 3. So for step 4, the substrate, enzyme-specific substrate is added. But for this last step, just a substrate binding to the enzyme, producing a reaction product. The amount of color produced is inversely proportional to the amount of antigen in step 1. So if there's more antigen in step 1, that means there's a less color, less fluorescence, there's less of a signal given off at the end of step 4 here. So it's inversely proportional to the amount of antigen step 1. So high concentration antigen step 1